Okay, I'm going to do solving systems of linear equations all in one video. So there are three different things. We've got substitution, elimination, and then word problems where you kind of set it up and then decide what you want to do and do it either way. Um, I'm trying to get as many videos up as I can right away because I'll be out of town for a few days and videos are the thing that I won't be able to do at all at that time. I stole these problems directly from IXL, so they should be at any rate similar to what you're going to do on IXL, but they may not be in order of difficulty like they normally would be. Okay, so substitution means solve for one of the variables, and it may still have the other variable in it, but solve for one of them. So you either have x equals or y equals, and then you go plug it into the other equation to solve. So you take one of the equations where you can most simply write x equals or y equals, and then you plug into the other one. In this case, this one's pretty well already there. So we can substitute this value into that x. You never plug back into the same equation you used to get the equal sign to start with. So minus 4 times x, which we're substituting minus 2, minus y is 17. 8 minus y is 17. Don't forget when you have two minuses, you got minus minus, and it makes 1 plus. So then subtracting 8 minus y equals 9, y equals minus 9, but you're not through. These are two lines, right? One of them is like this, and one of them is like, let's see, that. So the solution is this point right here. So we need to find out both x and y. But x in this case is easy because they've already given it to us. So the answer is minus 2 minus 9. Okay, on this one, hopefully everything I copied isn't like this. X is given to you again, so you just plug this in. So minus 8 times 6 minus 10y is 2, minus 48 minus 10y is 2. So we'll add 48 minus 10y is 50. Y is minus 5. I'm beginning to believe that my reload method on IXL has gotten me a bunch of the same type of problem. If that's the case, then when we get to elimination, I'm going to do some of them in both directions. Okay, so we're going to put in 4, so 3 times 4 plus 4y is minus 20. 12 plus 4y is minus 20. So subtracting 12, 4y. Oh, the previous one I didn't write the end solution, but they had already given us x again, so we would have put x, comma, and then whatever the y value was, I forgot. 4y equals minus 32. Y equals minus 8. So 4 minus 8. Okay, I'm going to use some of these elimination ones for this. I'll find one that works well. Oops, that one would have. Okay, so let's do this one by substitution. I need to solve for one or the other. So I can solve easily for y here, somewhat easily for y there. So y equals 15 plus 6x. So adding 6x to both sides, I get a y equals. It came from this one, so I need to plug it in to the other one there. So minus 2x minus, and then I plug in the 15 plus 6x equals 1. So minus 2x minus 15 minus 6x is 1. So minus 8x minus 15 is 1. So I'm going to add 15 to both sides. Minus 8x is now 16. X is minus 2. So now we need to go back and find out what y is, but we already have y in terms of x here. So 15 plus 6 times, and I plug in the minus 2. So that's 15 minus 12 is 3. So minus 2, 3 is my total solution doing this one by substitution. See if there's another one that I can, yeah. Okay, I'm going to solve this one by substitution too, and then we'll go on to elimination. This entire line here can be divided by 2. In fact, it can be divided by negative 2, in which case I get positive x plus positive y equals positive 4. And then I can solve for either x or y. So either x is 4 minus y, or y is 4 minus x. I think I'll solve for x just because I have to multiply by a lesser thing there. So this is x is 4 minus y. Now remember, it came from this line, so I can't use this line. So I have to substitute this 4 minus y in for the x on the first one. Minus 2 times 4 minus y minus 3y equals negative 18. So distributing here, minus 8 minus minus 2y minus 3y is minus 18. So minus 8 plus 2y minus 3y is minus y. Adding 8 minus y is minus 10. Y is 10. And so x is 4 minus 10, or minus 6. So minus 6, 10 is the answer to the problem. Okay, now I'm going to look at solving by elimination, and I think a couple of times I'll probably do it in the way that doesn't make the most sense so that you can see a slightly more complicated way. But basically, elimination works on the fact that if I have two things that are equal and two other things that are equal, then I can add the two left-hand sides and add the two right-hand sides, or subtract the left-hand side, subtract the right-hand side. As long as I do the same thing with them, because they're equal, I can add or subtract equal things from equal things, and everything stays equal. So, in this case, the easiest thing to do, you look at the values next to the x's and y's, and you're trying to eliminate x or eliminate y. Because the x has negative 6 and 6, it's the easiest thing to eliminate. So basically, we're just going to take this whole thing and add it to this whole thing. So minus 6x plus 6x goes to nothing. So that part gets eliminated right there. 4y plus minus 5y is minus y. 4 plus minus 11 is minus 7. So y is 7. So that got us to the first value faster, but solving for x will be less fast because we don't already have this kind of x equals like we had before. So y equals 7 minus 6x plus 4 times 7 equals 4. When you solve by elimination, you can go back and plug into either one. It doesn't matter, so I'm just plugging into the top. So minus 6x plus 28 equals 4. Subtracting 28 minus 6x equals negative 24. So x is 4. So the way you write the answer is 4, 7, the ordered pair. Now this one, some people, when they teach elimination, teach to always add. And if we were going to always add, then we'd multiply one of these whole things by -1. To me, we might as well just subtract, because you can add and subtract as well. So if I subtract that whole thing, because these two match, the -2 and the -2 already match each other, so I might as well just subtract the whole thing instead of multiplying this whole thing by by -1. So I'll do it, actually I'll do this one maybe 3 different ways. So if I just subtract, -2x minus -2x cancels. -3y minus -2y, so that's -3 plus 2, so that's -y. -18 minus a -8, so -18 plus 8 is -10. So y is 10. Minus 2x minus 3 times 10 is -18. Minus 2x minus 30 is -18. -2x equals, adding 30 to both sides, we get 12. X is -6. So -6, 10. Now, suppose that I did it the other way. Suppose I just rewrote it. -2x minus 3y is -18, and suppose I just change all these signs. So I'm multiplying through by -1. Positive 2x, positive 2y, positive 8. And if one of these would have been positive, then it would be negative now. So then I'm going to add them. So these still cancel. -y equals -10. So this is then exactly the same after that. So this one actually works exactly the same. I'm going to do something else because I don't think that any of these have where it doesn't automatically work out, and sometimes it doesn't. So sometimes you won't have two that match identically. You won't have -2 and -2 or -2 and +2. You'll have them all not have something in common. So I'm going to look at this one as if I didn't notice that these matched, and as if I wanted to eliminate y. So what I would do, if I start out with this and this, and for whatever reason I was bound and determined to eliminate y, then I would try to get their common multiple. So the least common multiple of 3 and 2 is 6. So to make that 3 a 6, I'd multiply this by 2. If I really wanted to just add, then I'd multiply this by -3. And so what we're going to have is -6 and +6. So minus 4x minus 6y is minus 36. 6x plus 6y is 24. And then I just add them. So these two eliminate. So I get minus 2x is minus 12. Oh, sorry, positive 2x. 6 minus 4. So x is -6. And then I'd go plug in the -6 to get the 10. But see, I get the same solution no matter how I do this. Okay, so this is another one that has them matching exactly. So I would, again, just subtract the whole thing. It's just really, if it bothers you to do that, if you're bothered by having to change all the signs in your mind, then you just come over and change all the signs. And it's the same thing. So I would have 7x minus 6y equals -7. Change all the signs, minus 8x plus 6y equals positive 14. And now these will cancel, and I'll have minus x over here and 7 over here, so x is negative 7. But I still need to solve for y, so 7 times negative 7 minus 6y is negative 7. Negative 49 minus 6y equals negative 7, so adding 49 minus 6y is 42. Y is also negative 7. And that's that. This one, you would have a choice. So these two match exactly. These two are opposites, so do whatever you want. Add or subtract, it doesn't matter. So I'll add, because most people prefer that. So I have 4x, the y's go away, and negative 17 plus negative 3 is negative 20. X is minus 5. We can plug in minus 5, or we can re-eliminate in the other direction. So if I wanted, I can do minus all of that so that the x's go away. I have 7y plus 7y is 14y. Negative 7 plus negative 17 plus 3, so negative 14, so y equals negative 1. So again, I could have also just plugged back in right here. 2 times negative 5 plus 7y is negative 17. Negative 10 plus 7y is negative 17. Adding 10, 7y is negative 7. Y is negative 1. So really, you have a lot of options on how to solve these. And if you do it right every time, you'll get the same answer, or else there's something wrong with math, right? Okay. So for this one, I'm going to do this a couple of different ways. I'm going to just add and straight eliminate over here. So negative 2x plus negative 6x is negative 8x. Negative y plus y gone. 1 plus 15 is 16. X is negative 2. Negative 2 times negative 2 minus y is 1. Minus 4 minus y is 1. Minus y equals, adding the 4, 5. Y is negative 5. Okay, so that's 1. And then suppose that I really wanted to eliminate x. Because you will have to eliminate in this way that's not quite so straightforward. I just didn't happen to copy any problems like that. Okay, so suppose I want to eliminate x. 6 and 2 have a common multiple of 6. So I would multiply this maybe by negative 3 if I really wanted to add instead of subtract. So I would get positive 6x, positive 3y, because I have two negatives and those make a plus, equals negative 3. And now I would add, and these go away, and then 4y equals 15 minus 3, so y equals 3, which means I went wrong over here. Minus 2 times minus 2 minus y equals 1. Oh, positive 4 right there, minus y equals 1. So 1 minus 4 is negative 3. So positive y equals positive 3. Okay? So y equals 3 over here, doing it this way, and then you'd have to solve for x. So minus 2x minus 3 equals 1. minus 2x equals adding 3 to minus 2x. Adding 3 makes 4. I'm just going to scribble that part. That's scribble. Okay, obviously I'm getting too tired, but I'm going to see if we can get through the word problems without taking a break. I've been also making videos for the other class, so. Okay, minus 2x minus 3 is 1. So minus 2x is 4 because we add 3, not subtract 3. So x is minus 2. Phew, okay. Oh boy. So we had one more of those. Okay, so on this one, the easiest thing to eliminate is the y, because 10 and 4, we could do it, and in fact, you could divide this through by 2. You can divide this one through by 4. You can then use substitution. You have a lot of options actually for this, but it's fairly straightforward just to add it to get rid of those. So let's do that. So 10x minus 4x is 6x. These go away. 20 plus 4 is 24. X is 4. So minus 4 times 4 plus 4y is 4. So negative 16 plus 4y equals 4. Adding 16, 4y is 20. Y is 5. Okay, so with word problems, basically in all word problems, the thing that it asks you at the end to answer is the thing that you need to name, that you need to give a variable to. So the biggest problem, I think, with setting up equations for word problems is not keeping that in mind, not being sure what to name. So let's look at this, and if you wanted, you could even, if you really have a hard time setting up word problems, you could even go ahead and look at the end. I'm going to change the pen color. You could look at the end and see what it's asking for. So it's asking for blank months and blank centimeters. So we might as well go ahead and label M is the number of months, and let's say L is the centimeters long. So they're the blanks we have to fill in, so that's what we need to name. So two friends, Dana and Vicky, are growing out their hair. They plan to cut it off at a certain point and donate it to a charity that makes wigs for people with cancer. Dana's hair is already 19 centimeters long, and it grows at a constant rate of 3 centimeters per month. So 19 plus 3 times the number of months is the total length of Dana's hair. Vicky's hair is 31 centimeters, so I'm going to put a little D just so for us to remember that that's for Dana. Vicky's hair is 31 centimeters and growing at a speed of 1 centimeter per month, so it's only adding 1 for every month. And that's the length for Vicky. If the girls get their hair cut on a certain day, they will have exactly the same length to donate. So that means these two are the same. So we can forget the subscript and say these equal L. How long will that take, and how long will their hair be? Okay, so now we have a system. 19 plus 3m is L, 31 plus m is L. The easiest way to solve this is substitution, putting this one for the other one. So 19 plus 3m equals, and now I'm going to substitute this for L, 31 plus M. Subtracting 12, 3M, or no, subtracting 19, sorry, so we 12 plus M, subtracting M, 2M is 12. So in 6 months, their hair will be 31 plus 6 is 37 centimeters long. Okay, so these systems are probably going to be similar again because I did the reload thing on the IXL. If I need to make videos for different types of setups, I will, and maybe I'll even make one up at the end here. Well, no, probably this will be enough for you to understand how to do word problems because it's really an issue of labeling. So in this case, for blank hours of parking, so let's let H be the number of hours that they parked. I guess I'm off the slide there. Mike and Nolan both ended up paying, we'll say D dollars, okay? So, or number of dollars, amount of money. Mike and Nolan met for dinner in downtown Belleville. Mike did flat rate valet parking for $12. So the total dollar amount for Mike is $12. Nolan went to another valet and paid $8 up front, so the dollars for Nolan is $8 up front and $1 per hour, so plus 1 times H, the number of hours. Ultimately, they ended up paying the same amount. So how long did they stay? Well, if they paid the same amount, they both paid $12 because we already know that's what Mike paid. But also, then the D's are the same. So 12 is 8 plus H. So subtracting 8, 4 is H. So they parked 4 hours. Okay, Monica is training for a triathlon. She's got blank laps and blank meters. So we'll say L is the number of laps and D we'll say is the number of meters, and that's just D for distance. Okay, if she swims at a rec center pool, she will complete a 91-meter warm-up and then swim laps in a lane that is 36 meters long. So this is the rec center pool. So the distance for the rec center pool is 91 meters plus 36 meters times the number of laps. If Monica swims at the indoor pool at her gym, so the distance for the gym, she does a 231-meter warm-up plus 29-meter laps, so 29 times the number of laps. If she swims the correct number of laps, she can complete the same distance in either pool. So again, we set these equal, so 91 plus 36L equals 231 plus 29L. So subtracting 91, get 36L equals 140 plus 29L. Subtracting 29L, we get 7L is 140, so L is 20. So she's going to swim 20 laps, and it's going to be then that the total distance is 91 plus 36 times 20, which is 91 plus 720, which is 811 meters. Okay, so this is the last one on this. And please send me a message if you're having trouble with some of the system word problems on IXL, and I'll go through a couple to get to a different kind and make a new video for that. An employee at a company that assembles chandeliers is packing boxes for shipping. Okay, we first look at the end. Each small chandelier weighs blank pounds, and each large one weighs blank pounds. So because they're both weight and they're both pounds, let's not use W or P. The difference between them is the small and large. So let's say S is the weight of the small, and let's say L is the weight of the large, and of course it's in pounds. Okay, so an employee at a company that assembles chandeliers is packing boxes for shipping. In the first box, he packed 5 small chandeliers and 1 large. So 5 times the weight of the small plus 1 times the weight of the large, and it weighed a total of 128, so equals 128. In the second box, he had 6 small ones and 5 large ones, and that was 336 total. So, assuming that the weight of the box isn't included, the question is, what is S and what is L? Okay, so the first thing is, you can do this either by elimination or substitution, and it's up to you. I personally would use substitution because of this 1L. I can easily solve for L. L is 128 minus 5S. And then I can plug this into the other equation there. So 6S plus 5 times 128 minus 5S. So 6S plus 5 times 128 is 640. So minus 25S is 336. 6x minus 25s, 640 minus 19s is 336. Subtracting 640 from both sides, minus 19s is negative 306. Dividing by 19, or negative 19, oh, that should have been a 4, yeah, 304. Okay, so that's 16. Each small one weighs 16. And then we know that 5 times 16 plus L is 128. Or L is 128 minus 5 times 16. So L is 128 minus 80. It's 5 times 16. So that's 48. Okay, so this concludes our substitution, elimination, and our word problems. And again, the IXL is posted for you to practice, and I will create an assessment for this probably over the next few days, but you can get your practice in now.